Boys and girls, today we are on lesson 9.7, the last lesson in fractions, on page 545. Today we're looking at equivalent fractions, and with a focus on how we can use models to name equivalent fractions. The fraction strips we made, they will definitely help us out on this lesson today. Alright, let's get started with Unlock the Problem. It says Cole brought a submarine sandwich to the picnic. He shared the sandwich equally with 3 friends. So he shared it with 3 friends, meaning there were probably 4 total, right? The sandwich was cut into eighths. What are 2 ways to describe the part of the sandwich each friend ate? So 2 ways to describe it. Okay. Right here it says Cole grouped the smaller pieces into 2s. And it says draw each circle to show equal groups of 2 pieces to show what each friend ate. Alright, so putting them into smaller pieces, the smaller pieces into groups of 2. So we'll have a group of 2 here, and then a group of 2 here, a group of 2 here, and finally a group of 2 here. So now if you look at my picture, I use the 4 different colors just so it's easier to look at. It says there are 4 equal groups, right? So I have my 4 equal groups. I have 1 group here, 2 groups, 3 groups, 4 groups. Each group then we know by now is 1/4, since there are 4 pieces, 1/4 of the whole sandwich. So each friend ate 1/4 of the whole sandwich. Here our question though is how many eighths did each friend eat? So if I'll change my color maybe to, let's go with purple. Alright, now we count the eighths in purple. There's 1, 2, 3, 4, 5, 6, 7, 8 purple pieces, and those are eighths now. And how many eighths did each friend eat? Well, if we look at the blue one right here, they ate 1/4, but there are actually 2 eighths in there. So each friend ate 2 eighths. So that means 1/4 and 2 eighths are equivalent fractions, since they both name the same amount of the sandwich. Okay, now the numbers are different, but the fractions themselves are the same or similar, right? So the yellow one right here, that's 1/4, but in purple it would be 2 eighths, and they are equivalent, equal. So 1/4 and 2 eighths of the sandwich are 2 ways to describe the part of the sandwich each friend ate. One way would be to say 1/4, the other way would be to say 2 eighths. And I guess I missed that here. How many people shared the sandwich? That was 4. Okay. Try this. Circle equal groups. Write an equivalent fraction for the shaded part. So we're going to circle equal groups and write an equivalent fraction. So here we have 4 eighths. They shaded in 4 eighths. 1, 2, 3, 4. But if we look at it in different groupings, and actually we can look at the shaded part right there and the unshaded part. Each side has 4 eighths in it, right? So they're equal. But now I put my 2 rectangles around there, and how many do I have that way? I have 1 here, and I have a second rectangle there that are the same size. That's important. So 4 eighths, or I could say how much is shaded in? 1/2 is shaded in. Okay, because I made the 2 rectangles the same size. Each one was 4 eighths, and one of them shaded in, the other one's not, so that's 1/2. So that means 4 eighths and 1/2 are equivalent fractions. Okay, let's go to the next page. Model the problem. And this one says Heidi ate 3/6 of her fruit bar Molly ate 4/8 of her fruit bar, which is the same size. The fruit bar is the same size. Which girl ate more of her fruit bar? So the first thing we're going to do is shade 3/6 of Heidi's bar. There it is, 3/6. Shade that in. I'm going to choose, let's go with yellow. Shade in 3/6 of Heidi's. Okay, there's Heidi's. And then it says 4/8. Shade in 4/8 of Molly's fruit bar. So we go to Molly's, 4/8 of that one, and it helps if I use the right pen. 4/8 of Molly's is this amount right here. Okay. Is 3/6 greater than, less than, or equal to 4/8? Okay. So we're not looking at the numbers here. The numbers, the denominator of 8 might possibly throw us off, or the denominator of 6 might throw us off. Or if we look at Heidi, she has 3/6 that she ate. The numerator is 3. And if we look at Molly, she ate 4/8, and the numerator is 4. If we look at just those numbers, that will confuse us and throw us off. We need to look at the picture instead. So we're going to look at that whole picture and that whole picture. Okay? So if we look at the size of each one, and I'll highlight that part right here. There's Heidi, and here's Molly. Those are the same size. So 3/6 and 4/8 are the same. Now if you use your fraction strips that we created, it's probably a little bit easier to see when you compare 3/6 and 4/8 on your fraction strips that you made. Okay, so, I guess I shouldn't write same. They wanted greater than, less than, or equal to, and they are equal. EQUAL. Alright, so both girls ate the blank amount, they ate the same amount. This is where I want to write same. SAME, same. It says try this. Each shape is one whole. Write an equivalent fraction for the shaded parts of the model. Okay, now these are the ones that always seem to be really tricky for us when we have our numerator bigger than our denominator. But it's not that confusing. If I write a fraction like this, you know that we have something divided into 3 parts and we color in 2 of them, right? You guys know that by now. So if we have something like this instead, again, we have something divided into 3 parts and we color in 6 of them. So there's 1, 2, 3. Oh, I need to draw another one that has 3 parts, like that, and then I shade in those. 4, 5, 6. So we just keep making thirds until we've filled in as many as we need to, and in this case, 6. Alright, so let's take a look at our example problem now over here. Let me redo that. There we go. Okay. So we need to shade in 6/3, it says right here, right? 6/3, right here. Shading in 6/3. So I come over here and I shade in 6/3. There's 1, 2, 3, 4, 5, 6. Each one of these, sorry about that, each one of these is divided into thirds, and that one's divided into thirds. I've shaded in 3 of these and 3 of these, so now I have 6 shaded in. That's 6/3 then. Okay, we need to find the equivalent fraction of 6/3 in these 2 models. Okay, but I guess the first question I would ask, how many whole shapes did I color in here. I colored in that whole shape and that whole shape. So I colored in 2 whole shapes. That means I need to color in the same number of whole shapes here. Since I colored in 2 whole shapes on the other one, I need to color in 2 whole shapes here. So I color in this one, all parts of it. Now I've colored in a whole shape. I've colored in 1 whole shape. I need to color in 2 whole shapes though. And as soon as I finish these up, now I've shaded in 2 whole shapes. Okay, so we need to write the fraction for that right here. All right, so they already told us that these shapes are divided into 6 equal parts, and that's why the denominator is 6, because they're both shaded into sixths. Okay, now we have to figure out the numerator, and all we have to do there is count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I colored in or shaded in 12 sixths. So I can write 12 right here. 6/3 is the same as 12 sixths. Now you don't have to know this next part, but I think it's a really cool trick that might help you out eventually. If I look at the denominator and I think of what do I have to multiply that denominator by to get the numerator, I would multiply 3 times something to equal 6, and that something would be 2. So that means I can take any other denominator, including this 6, and if I can take 6 times 2, it will equal 12. And then that I know is the numerator I can put here, so these 2 fractions are equivalent. Okay, so if I take a denominator, multiply it times a number, I'll get my numerator. Then I can take another denominator, multiply it times the same number, and get a different numerator, but those 2 fractions would be equal or equivalent. Let me show you a different example real quick. Let's make up one with fourths. I'll say 4 times, what's 4 times 3? Right? 4 times 3 equals 12. Okay, so then 12 fourths, okay, is going to be equal to, let's say something over 10. Well, 10 times 3, remember I multiplied the top one up there by 3, so I'm going to multiply this one times 3. 10 times 3 equals 30. So then I can take my 30, put it here. 12 fourths is equivalent or equal to 30 tenths. I multiplied both denominators by 3, so then my fractions stayed the same, or equivalent. Again, you don't have to know that right now. That is something you'll learn probably in 4th or 5th grade. Alright, boys and girls, that's it for the video today. As always, this is Mr. P, and I am out.